Hello there, and welcome to this quiet corner where curiosity gets cozy and science takes the scenic route to slumber. I'm your guide tonight, and I'd love to know where in the world you're listening from and what time it is right now. Are you settling in for the night? Perhaps stealing a peaceful moment during your day? Or maybe you're somewhere in between, in that beautiful space where the mind begins to wander. Tonight, we're going to explore one of the most mysterious things you do every single day, or rather, every single night. Something so extraordinary that if I told you about it without you experiencing it yourself, you might think I was describing pure magic. Right now, as you listen to my voice, your brain is preparing for tonight's adventure. An adventure you'll take whether you remember it or not. And here's what might shock you about this nightly journey. You might think dreams are just random electrical noise, meaningless fragments of a tired brain shutting down for the night. But the truth is far more extraordinary than anything your waking mind could imagine. Picture this. Tonight, while you lie perfectly still, your brain will become more active than when you're solving the most complex problems. Your eyes will dart back and forth beneath closed lids as if you're watching the most captivating movie ever made. Your brain will paralyze your entire body to prevent you from acting out epic adventures that feel absolutely real. And here's the part that will leave you breathless. Your sleeping mind will solve problems your waking brain couldn't crack, process emotions too complex for conscious thought, and create entire worlds complete with impossible physics, vivid characters, and storylines that would make Hollywood writers weep with envy. In your lifetime, you'll spend roughly 6 years dreaming. 6 entire years. That's 2,190 nights of vivid experiences, epic journeys, and adventures that defy every law of reality. Imagine if I told you that you had a secret life, a parallel existence where you could fly, meet people who don't exist, visit places that were never built, and experience emotions so intense they follow you into your waking hours. You'd think I was describing science fiction, but I'm describing last night, and tonight, and every night of your life. But here's where the story takes an incredible turn. Scientists recently made a discovery that changes everything we thought. We knew about those mysterious hours when consciousness fades. They discovered that your brain doesn't just randomly dream. It carefully, deliberately chooses what to dream about. And those choices, those selections your sleeping mind makes, might hold the key to who you are. How you learn, how you heal, and how you solve the unsolvable, right now in your brain. 100 billion neurons are preparing for tonight's performance. That's more computing power than the most advanced supercomputers on Earth. And what your brain does with that power during dreams might be the reason you can remember your first kiss, recover from heartbreak, and wake up with solutions to problems that seemed impossible the day before. I should probably mention that talking about sleep science might actually help you sleep better tonight. So consider this your friendly neighborhood scientist, accidentally doubling as the most scientifically accurate sleep aid you've ever encountered. If you enjoy this gentle journey into the science of dreams, a like helps other curious minds find this cozy corner of the internet where wonder meets slumber. But here's something that happened in a laboratory in 1953 that I need to tell you about, because it reveals a secret about your sleeping mind that even today scientists are still trying to fully understand. A graduate student was watching his 8-year-old son sleep through a makeshift contraption in his basement. He was monitoring his son's brainwaves, expecting to see the quiet, flat lines of a resting mind. Instead, at 3:37 in the morning, something impossible appeared on his primitive equipment. The brainwaves spiked dramatically, showing activity that rivaled being wide awake. The child's eyes began moving rapidly beneath closed lids, back and forth, as if watching invisible tennis matches. The student almost dismissed it as equipment failure. After all, how could a deeply sleeping brain be more active than a conscious one? But something made him wake his son at that exact moment, and what the 8-year-old told his father would revolutionize everything we understand about the human mind. The child described a vivid, detailed dream, complete with colors, sounds, emotions, and a storyline that had been unfolding for what felt like hours. That moment of curiosity in a basement laboratory opened the door to one of the most profound mysteries of human existence. Because what that graduate student discovered wasn't just that we dream. He discovered when we dream, how we dream, and most importantly, that dreaming isn't random chaos. It's organized, purposeful, and absolutely essential for human consciousness. What we're about to explore together might just change how you see those quiet hours when your conscious mind steps aside and something far more mysterious takes over. We'll discover why evolution kept this vulnerable state where we're completely defenseless yet utterly absorbed in inner worlds. We'll uncover what your brain is really doing while you sleep, and why your most vivid dreams happen when you're closest to waking up. So settle in, get comfortable, and prepare for a journey into the most fascinating territory you visit every night. The science of dreams is waiting to reveal its secrets, and trust me, reality is far stranger and more beautiful than any dream you've ever had. What the 8-year-old boy told his father in that basement laboratory would become the key that unlocked one of the greatest mysteries of human consciousness. When his father gently woke him during those rapid eye movements, the child didn't describe the foggy confusion you might expect from disturbed sleep. Instead, his eyes lit up with excitement as he recounted a vivid adventure. He had been flying over a magical landscape, talking to animals that spoke back, and exploring a castle that defied all laws of architecture. The dream felt so real that the boy was disappointed to discover he was back in the ordinary world of his bedroom. Eugene Acerensky, that graduate student, realized he had stumbled upon something revolutionary. If dreams only happened during these periods of intense brain activity, then sleep wasn't just one uniform state of unconsciousness. It was a complex, organized process with distinct phases, each serving a different purpose. That discovery in 1953 opened the door to understanding that your brain doesn't simply shut down when you close your eyes. It transforms into something entirely different. What Acerensky had discovered was REM sleep, named for those rapid eye movements that betrayed the intense mental activity happening behind closed lids. But REM was just one piece of a far more intricate puzzle. Your nightly journey through sleep is actually a carefully choreographed dance of 4 distinct stages, each one essential for your mental and physical well-being. Think of sleep like a theater production that runs every single night in the auditorium of your mind. The curtain rises slowly with stage 1, light sleep, where you're dipping your toe into the waters of unconsciousness. Your brain waves begin to slow from the rapid beta waves of alertness to the gentler alpha and theta rhythms. This is the threshold between waking and sleeping, where you might still hear sounds from the outside world, but they begin to fade like distant music. Then comes stage 2, where your brain starts its nightly housekeeping routine. This isn't just rest, it's active maintenance. Your brain temperature drops slightly, your heart rate slows, and something fascinating begins to happen. Your brain produces sudden bursts of activity called sleep spindles. brief explosions of electrical activity that actually protect your sleep from being disturbed by external noises. It's as if your brain builds a sound barrier around your consciousness. Stage 3 is where the real magic of restoration begins. This is deep sleep, the phase where your body becomes a repair shop working at maximum efficiency. Your brain waves slow to powerful delta rhythms, rolling through your neural networks like gentle ocean swells. During this phase, your pituitary gland releases growth hormone, your immune system strengthens its defenses, and your brain begins one of the most remarkable processes in all of biology. Eugene A. Serensky, that graduate student, realized he had stumbled upon something revolutionary. If dreams only happened during these periods of intense brain activity, then sleep wasn't just one uniform state of unconsciousness. It was a complex, organized process with distinct phases, each serving a different purpose. That discovery in 1953 opened the door to understanding that your brain doesn't simply shut down when you close your eyes. It transforms into something entirely different. What Serensky had discovered was REM sleep, named for those rapid eye movements that betrayed the intense mental activity happening behind closed lids. But REM was just one piece of a far more intricate puzzle. Your nightly journey through sleep is actually a carefully choreographed dance of 4 distinct stages, each one essential for your mental and physical well-being. Think of sleep like a theater production that runs every single night in the auditorium of your mind. The curtain rises slowly with stage 1, light sleep, where you're dipping your toe into the waters of unconsciousness. Your brain waves begin to slow from the rapid beta waves of alertness to the gentler alpha and theta rhythms. This is the threshold between waking and sleeping, where you might still hear sounds from the outside world, but they begin to fade like distant music. Then comes stage 2, where your brain starts its nightly housekeeping routine. This isn't just rest, it's active maintenance. Your brain temperature drops slightly, your heart rate slows, and something fascinating begins to happen. Your brain produces sudden bursts of activity called sleep spindles, brief explosions of electrical activity that actually protect your sleep from being disturbed by external noises. It's as if your brain builds a sound barrier around your consciousness. Stage 3 is where the real magic of restoration begins. This is deep sleep, the phase where your body becomes a repair shop working at maximum efficiency. Your brain waves slow to powerful delta rhythms, rolling through your neural networks like gentle ocean swells. During this phase, your pituitary gland releases growth hormone, your immune system strengthens its defenses, and your brain begins one of the most remarkable processes in all of biology. This is why your most vivid, memorable dreams happen just before you wake up. Your brain has been rehearsing all night, and by dawn, it's putting on its most spectacular performance. Those epic dreams that feel like they last for hours are actually condensed into these extended REM periods near morning. Right now, as you listen to these words, your brain is already beginning its preparation for tonight's journey. Your circadian rhythms are shifting, your body temperature is starting its gradual decline, and the neurochemicals that will orchestrate your sleep cycles are beginning their delicate dance. In just a few hours, you'll embark on a journey that takes you through landscapes that exist nowhere but in the theater of your mind. But what exactly happens during these dreams? How does your brain create experiences so vivid that they can feel more real than waking life? And why does your dreaming mind choose the particular stories, characters, and scenarios that populate your nightly adventures? The answers to these questions reveal something profound about the very nature of consciousness itself your sleeping brain isn't just randomly firing neurons. It's engaged in some of the most sophisticated information processing in the known universe. Every dream is a masterpiece of creativity, a complex narrative woven from memory, emotion, anticipation, and pure imagination. And the way your brain accomplishes this feat of mental artistry would leave the most advanced artificial intelligence systems struggling to keep up. The moment your head touches the pillow tonight, your brain will begin one of the most sophisticated processes in all of biology. But what actually happens in those crucial first moments of sleep would surprise you. You might expect your brain to simply power down like a computer, but instead, it transforms into something entirely different, something that operates according to rules that would seem impossible if you didn't experience them every night. The journey begins not with dreams, but with something far more fundamental. As your brainwaves slow from the rapid fire of conscious thought, a remarkable chemical transformation begins. The neurotransmitters that keep you alert and focused during the day begin to fade, while entirely different chemicals take center stage. Adenosine, the molecule that creates your feeling of tiredness, has been building up in your brain all day like sand filling an hourglass. Now, as sleep approaches, this chemical pressure finally tips your brain into its first stage of rest. But here's where the story takes an unexpected turn. You'd think dreams start immediately when you fall asleep, but your brain has other priorities. First, during those initial hours of sleep, while you're cycling through the deeper stages, your brain is actually engaged in a massive reorganization project that would impress the most efficient librarian. Picture your mind as a vast library, where thousands of books have been pulled from the shelves during the day. Every experience, every conversation, every thought has created a small pile of information somewhere in your mental space. Now, during deep sleep, your brain becomes the ultimate librarian, carefully examining each piece of information and deciding what deserves a permanent place in your long-term memory and what can be discarded. This process involves one of the most elegant partnerships in neuroscience. Your hippocampus, a seahorse-shaped structure deep in your brain, acts as a temporary holding area for the day's experiences. Think of it as an inbox where everything gets stored initially, but the hippocampus can't hold on to information forever. During deep sleep, it begins a careful conversation with your cortex, the outer layer of your brain where permanent memories live. The hippocampus replays the day's experiences like a filmmaker reviewing footage, sending patterns of activity to the cortex. But this isn't just random replay. Your brain is actually deciding which memories are worth keeping based on emotional significance, repetition, and relevance to your existing knowledge. A casual conversation with a stranger might get deleted, while a meaningful moment with someone you love gets carefully filed away for a lifetime. And here's something that happens during this process that would astound you if you could observe it directly. Your brain doesn't just store memories as static files. It actually strengthens the neural pathways associated with important skills and knowledge. If you spent the day learning to play a musical instrument, your sleeping brain will rehearse those motor patterns, literally practicing while you rest. This is why students who sleep after studying often perform better than those who stay awake cramming. But the real magic begins when your brain shifts into REM sleep, when the theater of dreams finally opens its curtains. The transformation that occurs during this shift is so dramatic that it's like watching a quiet library suddenly become a bustling carnival. Your brainstem releases a flood of acetylcholine, a neurotransmitter that acts like a master switch, activating the visual motor, and emotional centers of your brain, while simultaneously shutting down your ability to form coherent, logical thoughts. This is why dreams feel so real in the moment, but seem so bizarre when you try to analyze them afterward. Your visual cortex becomes incredibly active, creating the vivid imagery of dreams, while your prefrontal cortex, the part of your brain responsible for logical thinking and reality testing, essentially goes offline. It's like having the world's most sophisticated movie projector running while the film critic has left the theater. The paralysis that occurs during REM sleep is orchestrated by a group of neurons in your brainstem that release chemicals called glycine and GABA. These molecules prevent the motor signals from your dreaming brain from reaching your muscles. It's a safety mechanism so precise that it can distinguish between the movements you need to survive, like breathing, and the movements that would be dangerous, like acting out a dream about running or fighting. But your eyes are exempt from this paralysis, and for a fascinating reason. The same neural networks that generate the visual imagery of dreams also control eye movements. So when you're dreaming about watching a butterfly flutter from flower to flower, your eyes are actually tracking that imaginary butterfly. When you dream about reading a book, your eyes make the same scanning movements they would make if you were actually reading. The content of your dreams isn't random either. Your dreaming brain draws from a vast database of memories, but it combines them in ways that your waking mind would never consider. It might take your childhood home, populate it with people from your current workplace, and create a story that involves flying to the grocery store. This isn't malfunction. It's your brain's way of making novel connections between different areas of your experience. Your emotional brain, centered in the amygdala, becomes hyperactive during REM sleep. This is why dreams often involve intense emotions, from joy to terror to love to frustration. Your dreaming brain is actually processing and integrating the emotional experiences of your waking life, helping you make sense of complex feelings and relationships. This emotional processing is so important that people who are deprived of REM sleep often experience mood disturbances and difficulty regulating emotions. The timing of your dreams is precisely controlled by your brain's internal clock, your circadian rhythm. This biological timekeeper, synchronized by light and darkness, determines when your brain releases melatonin to promote sleep, and when it stops producing this sleep hormone to help you wake up. Your REM periods are clustered toward the end of the night, when your body temperature is at its lowest and your cortisol levels are beginning to rise in preparation for waking. What's truly remarkable is how your brain maintains the dream narrative across brief awakenings. You might wake up for a few seconds during the night, perhaps to adjust your position or respond to a sound, and then return to sleep and continue the same dream where you left off. Your brain somehow holds onto the dream story and characters, picking up the narrative thread seamlessly. The neurotransmitter norepinephrine, which helps you stay alert and focused during the day, is almost completely absent during REM sleep. This absence is part of what allows your dreaming mind to make those bizarre, possible connections that seem so strange when you wake up. Without the logical constraints imposed by norepinephrine, your brain becomes incredibly creative, solving problems in ways that your rational mind might never consider. Some of history's greatest discoveries have emerged from this unique state of consciousness. Kekula's famous dream of a snake eating its own tail led to his discovery of the ring structure of benzene. Tesla visualized many of his inventions in dreams. The melody for Yesterday came to Paul McCartney in a dream so vivid that he woke up and immediately played it on his piano, worried that he had unconsciously plagiarized someone else's song. Your dreaming brain has access to your entire library. of memories, emotions, and knowledge, but it operates according to different rules than your waking consciousness. It prioritizes emotional significance over logical consistency, creates narratives that feel meaningful even when they defy physics, and makes connections that your rational mind might dismiss as impossible. This is the machinery that operates every night while you rest, transforming your brain from a logical processor into a creative storyteller, from a careful analyst into an emotional integrator, from a conscious observer into an unconscious explorer. Of infinite possibilities, to truly understand the magnitude of what happens in your dreaming brain, you need to shrink down to the microscopic level and witness the incredible dance of consciousness from the perspective of a single neuron. If you could miniaturize yourself and travel through your neural networks during a dream, you would find yourself in the middle of the most complex light show in the known universe. Each of your 100 billion neurons is connected to thousands of others, creating a network so vast that it contains more connections than there are stars in the Milky Way galaxy. During a single dream, electrical signals cascade through these networks like lightning storms, with each spark carrying fragments of memory, emotion, sensation, and pure imagination. The scale of this activity is so immense that your dreaming brain consumes nearly as much energy as your waking brain, despite the fact that you're lying perfectly still. Consider this breathtaking fact about the timing of your dreams. A dream that feels like it unfolds over several hours actually happens in just 10 to 30 minutes of real time. Your brain compresses entire narratives, complete with character development, plot twists, and emotional arcs, into these brief windows of REM sleep. This means your mind is operating at a temporal compression rate that would make the most advanced computers seem sluggish by comparison. This is the machinery that operates every night while you rest, transforming your brain from a logical processor into a creative storyteller, from a careful analyst into an emotional integrator, from a conscious observer into an unconscious explorer. Of infinite possibilities. To truly understand the magnitude of what happens in your dreaming brain, you need to shrink down to the microscopic level and witness the incredible dance of consciousness from the perspective of a single neuron. If you could miniaturize yourself and travel through your neural networks during a dream, you would find yourself in the middle of the most complex light show in the known universe. Each of your 100 billion neurons is connected to thousands of others, creating a network so vast that it contains more connections than there are stars in the Milky Way galaxy. During a single dream, electrical signals cascade through these networks like lightning storms, with each spark carrying fragments of memory, emotion, sensation, and pure imagination. The scale of this activity is so immense that your dreaming brain consumes nearly as much energy as your waking brain, despite the fact that you're lying perfectly still. Consider this breathtaking fact about the timing of your dreams. A dream that feels like it unfolds over several hours actually happens in just 10 to 30 minutes of real time. Your brain compresses entire narratives, complete with character development, plot twists, and emotional arcs, into these brief windows of REM sleep. This means your mind is operating at a temporal compression rate that would make the most advanced computers seem sluggish by comparison. During a typical night, you'll experience 4 to 6 complete sleep cycles, each lasting about 90 minutes. But here's what makes this schedule remarkable. Your brain doesn't just randomly cycle through these stages. It follows an ancient rhythm that has been fine-tuned by millions of years of evolution. This rhythm is so precise that sleep researchers can predict, within minutes, when you'll enter your next REM period, The scale of memory processing during sleep is equally staggering. Every day, your brain encounters approximately 11,000 pieces of new information. Your senses are constantly bombarded with sights, sounds, smells, textures, and tastes. You have conversations, read words, see faces, and navigate through complex environments. All of this information needs to be sorted. And sleep is when your brain performs this monumental task. During deep sleep, your hippocampus replays the day's experiences at 20 times the speed they originally occurred. Imagine watching an entire day of your life compressed into just over an hour, like a time-lapse video of your consciousness. This rapid replay allows your brain to extract patterns, identify important information, and integrate new knowledge. With everything you already know, but the connections your brain makes during sleep extend far beyond just processing the previous day's experiences. Your dreaming mind reaches back through your entire lifetime of memories, pulling together experiences from childhood, adolescence, and recent years. It might combine your first day of school with yesterday's work meeting, creating dream scenarios that feel emotionally meaningful even though they would be logically impossible. These connections span not just time, but also different types of information. Your dreaming brain connects memories with emotions, facts with feelings, visual images with sounds and smells. A single dream might weave together the color of your grandmother's kitchen, the sound of rain on your current roof, the feeling of anxiety from an upcoming deadline, and the face of a colleague you barely know. This type of cross-modal integration creates the rich, multisensory experience that makes dreams feel so vivid. The scale of this integration becomes even more impressive when you consider that your brain is doing all of this while maintaining your basic life functions. Your heart continues to beat, your lungs continue to breathe, your kidneys continue to filter your blood, and your immune system continues to patrol for threats. Sleep isn't a shutdown of your body's systems. It's a carefully coordinated shift in priorities. Your endocrine system, the network of glands that produces hormones, follows its own precisely timed schedule during sleep. Growth hormone surges during deep sleep, promoting tissue repair and regeneration. Cortisol levels drop to their lowest point in the early hours of sleep, then gradually rise toward morning to prepare you for waking. Melatonin floods your system in response to darkness, making you feel drowsy, then gradually decreases as dawn approaches. The connections between sleep and your immune system reveal another layer of the incredible coordination happening in your sleeping body. During deep sleep, your immune system produces more infection-fighting cells and antibodies. Your body temperature drops slightly, creating conditions that are less favorable for viruses and bacteria. Your lymphatic system, which clears waste from your tissues, becomes more active during sleep, essentially giving your entire body a nightly cleaning. Even your digestive system follows the rhythm of sleep. Your stomach acid production decreases, your intestinal movements slow down, and your liver shifts into its most active phase of detoxification. This is why eating late at night can disrupt your sleep. Your digestive system is expecting to rest and repair, not process a large meal. The connections extend to your cardiovascular system as well. Your blood pressure drops during sleep, giving your heart a chance to rest. Your blood vessels dilate slightly, improving circulation to your brain and other organs. This cardiovascular rest is so important that people who consistently get poor sleep have significantly higher risks of heart disease and stroke. Perhaps most fascinating are the connections between sleep and your brain's waste clearance system. Scientists recently discovered that your brain has its own version of the lymphatic system, called the glymphatic system. During sleep, this system becomes 10 times more active than during waking hours. The channels between your brain cells expand, allowing cerebrospinal fluid to flush out toxic proteins that accumulate during the day. This cleaning process is so thorough that it removes beta amyloid and tau proteins, the same substances that build up in the brains of people with Alzheimer's disease. In essence, your sleeping brain performs a nightly maintenance routine that may be one of your most important defenses against neurodegenerative diseases. The scale of learning that occurs during sleep is equally remarkable. If you spend time during the day practicing a new skill, whether it's playing piano, learning a language, or mastering a sport, your sleeping brain will continue to practice the same neural pathways that were active during your waking practice. Sessions will fire repeatedly during sleep, strengthening the connections and improving your performance. This sleep-dependent learning is so powerful that people often wake up better at skills they practiced the day before, even without any additional practice. Your brain essentially continues your training session while you rest, running through the movements, sounds, or concepts over and over again in a way that's impossible during waking hours when your attention is constantly shifting to new information. The temporal connections your brain makes during sleep are particularly intriguing. Your dreaming mind doesn't just process yesterday's experiences, it also seems to prepare for future scenarios. Dreams often involve situations you might encounter, problems you might need to solve, and challenges you might face. It's as if your sleeping brain is running simulations, preparing you for possibilities that haven't happened yet. This preparation extends to emotional scenarios as well. Dreams often involve intense social interactions, conflicts, reunions, and celebrations. Your dreaming brain might be helping you rehearse emotional responses, practice social skills, and prepare for the complex interpersonal challenges of waking life right now. As you listen to these words, all of these systems are preparing for tonight's performance. Your circadian clock is tracking the approaching darkness. Your adenosine levels are gradually building the pressure for sleep, and your brain is beginning the subtle chemical shifts that will transform your consciousness from its waking state into the mysterious realm of dreams. Long before Eugene Osirinsky watched his son's eyes move beneath closed lids, humans have been fascinated by the mysterious world of dreams. For thousands of years, dreams were considered messages from the gods, glimpses into the future, or journeys to other realms. The ancient Egyptians built dream temples where people would sleep in hopes of receiving divine guidance. The Greeks believed dreams were visits from the gods, and they recorded their dreams on stone tablets, treating them as sacred communications. In ancient Mesopotamia, the Epic of Gilgamesh, one of the oldest known stories in human history, revolves around prophetic dreams that guide the hero's journey. The ancient Chinese developed elaborate systems for interpreting dreams, believing they were communications between the earthly realm and the spirit world. Indigenous cultures around the world developed rich traditions around dreaming, with some considering the dream world to be just as real and important as waking life. This sleep-dependent learning is so powerful that people often wake up better at skills they practiced the day before, even without any additional practice. Your brain essentially continues your training session while you rest, running through the movements, sounds, or concepts over and over again in a way that's impossible during waking hours when your attention is constantly shifting to new information. The temporal connections your brain makes during sleep are particularly intriguing. Your dreaming mind doesn't just process yesterday's experiences, it also seems to prepare for future scenarios. Dreams often involve situations you might encounter, problems you might need to solve, and challenges you might face. It's as if your sleeping brain is running simulations, preparing you for possibilities that haven't happened yet. This preparation extends to emotional scenarios as well. Dreams often involve intense social interactions, conflicts, reunions, and celebrations. Your dreaming brain might be helping you rehearse emotional responses, practice social skills, and prepare for the complex interpersonal challenges of waking life. Right now, as you listen to these words, all of these systems are preparing for tonight's performance. Your circadian clock is tracking the approaching darkness. Your adenosine levels are gradually building the pressure for sleep, and your brain is beginning the subtle chemical shifts that will transform your consciousness from its waking state into the mysterious realm of dreams. Long before Eugene Osirinsky watched his son's eyes move beneath closed lids, humans have been fascinated by the mysterious world of dreams. For thousands of years, dreams were considered messages from the gods, glimpses into the future, or journeys to other realms. The ancient Egyptians built dream temples where people would sleep in hopes of receiving divine guidance. The Greeks believed dreams were visits from the gods, and they recorded their dreams on stone tablets, treating them as sacred communications. In ancient Mesopotamia, the Epic of Gilgamesh, one of the oldest known stories in human history, revolves around prophetic dreams that guide the hero's journey. The ancient Chinese developed elaborate systems for interpreting dreams, believing they were communications between the earthly realm and the spirit world. Indigenous cultures around the world developed rich traditions around dreaming, with some considering the dream world to be just as real and important as waking life. But it was in the late 19th century that scientists first began to suspect that dreams might have a biological rather than supernatural explanation. The invention of the electroencephalogram, or EEG, in 1924 gave researchers their first glimpse into the electrical activity of the sleeping brain. However, the early EEG machines were primitive, and the recordings showed only that the brain remained active during sleep. The specific patterns and stages of sleep remained hidden. The breakthrough came in the most unlikely of places, that basement laboratory where Eugene Osirinsky was pursuing his graduate studies in 1953. Osirinsky was working under Nathaniel Kleitman, a pioneering sleep researcher at the University of Chicago. Kleitman had already discovered that sleep wasn't just one uniform state, but seemed to have different phases. However, the technology of the time made it difficult to study these phases in detail. Osirinsky's decision to use his own 8-year-old son, Armand, as a research subject was born partly out of necessity and partly out of curiosity. Children were ideal research subjects because they slept more soundly than adults and were less likely to be disturbed by the primitive recording equipment. Night after night, Osirinsky would attach electrodes to his son's scalp and eyes, monitoring brain waves and eye movements throughout the sleep period. For weeks, the recordings showed the expected pattern of gradually slowing brain waves as sleep deepened. But then, on that fateful night in 1953, something extraordinary appeared on the paper recordings. At 3:37 in the morning, the brain waves suddenly spiked to levels that looked almost identical to waking patterns. Even more puzzling, the recording showed rapid, jerky movements of the eyes beneath closed lids. Osirinsky's first instinct was to check his equipment. The readings seemed impossible. How could a deeply sleeping brain show such intense activity? but the equipment was functioning perfectly. The child was clearly asleep, breathing deeply and lying motionless, yet his brain was as active as if he were awake and alert. The decision to wake his son at that moment was driven by scientific curiosity, but it must have taken considerable courage. Waking a sleeping child in the middle of the night for the sake of an experiment could easily have been dismissed as the action of an overzealous researcher. But when Armand opened his eyes and began describing a vivid, detailed dream, Aserinsky knew he had discovered something revolutionary. The dream Armand described wasn't the fuzzy, forgotten fragment that most people remember upon waking. It was a complete narrative with characters, dialogue, emotions, and a coherent storyline. The child could remember colors, sounds, and even specific conversations from his dream. This suggested that whatever was happening during these periods of intense brain activity, it was creating experiences as vivid and memorable as waking life. Aserinsky and Kleitman published their findings in 1953 in the journal Science, in a paper that would become one of the most influential publications in sleep research. They had discovered what they called rapid eye movement sleep, or REM sleep, and they had proven that this was when the most vivid dreams occurred. But this discovery raised more questions than it answered. If REM sleep was when the brain was most active, why had evolution preserved this seemingly vulnerable state? Why would a sleeping animal, defenseless against predators, maintain such high levels of brain activity? And why were the most intense dreams clustered toward the end of the night, when the danger of predation might be greatest? The answers to these questions would take decades to uncover, and they would revolutionize our understanding of consciousness itself. In the 1960s, researchers discovered that all mammals experience REM sleep, suggesting that this brain state evolved hundreds of millions of years ago. Even more intriguingly, they found that warm-blooded animals spend more time in REM sleep than cold-blooded animals, hinting at a connection between dreaming and the sophisticated neural processing required for complex behavior. The 1970s brought the discovery that REM sleep was crucial for learning and memory. Researchers found that people who were deprived of REM sleep, while still getting the same total amount of sleep, showed significant problems with memory formation and emotional regulation. This suggested that dreams weren't just random mental activity but served specific, important functions for brain health. Dr. William Dement, who had worked with Aserinsky and Kleitman, continued their research and made another startling discovery. He found that people deprived of REM sleep for several nights would experience REM rebound when they were finally allowed to sleep normally. Their brains would dramatically increase the amount of time spent in REM sleep, as if making up for lost dreaming time. This suggested that REM sleep wasn't just a nice-to-have feature of sleep, but an absolute biological necessity. The 1980s and 1990s brought increasingly sophisticated brain imaging technology that allowed researchers to see what was actually happening in the dreaming brain. PET scans and later fMRI machines revealed that during REM sleep, the visual cortex was as active as during waking vision, even though the eyes were closed. The emotional centers of the brain, particularly the amygdala, showed intense activity, explaining why dreams often involve such strong emotions. Perhaps most surprisingly, the prefrontal cortex, the brain region responsible for logical thinking and reality testing, showed decreased activity during REM sleep. This explained why dreams often involve impossible scenarios that seem perfectly reasonable while you're experiencing them. Your brain's fact-checker is essentially offline during dreams, allowing your mind to accept flying, talking animals, and impossible architecture as completely normal. The late 20th century brought the discovery of sleep's role in memory consolidation. Researchers found that information learned during the day was literally rehearsed during sleep, with the same neural pathways firing repeatedly during both slow-wave sleep and REM sleep. This wasn't just passive replay, but active strengthening of important memories and elimination of irrelevant information. Dr. Matthew Walker's research in the early 2000s revealed that sleep serves as an email inbox for memory formation. During the day, new information is temporarily stored in the hippocampus, but during sleep, important memories are transferred to the cortex for long-term storage. This process doesn't just preserve memories, but actually improves them, extracting general rules and patterns that can be applied to new situations. The most recent discoveries have been perhaps the most remarkable. In 2012, Dr. Micah Nediger discovered the brain's glymphatic system, revealing that sleep serves as a nightly cleaning cycle for the brain. During deep sleep, brain cells shrink, creating channels that allow cerebrospinal fluid to wash away toxic proteins. This discovery provided a biological explanation for why sleep deprivation is associated with neurodegenerative diseases. Current research is pushing the boundaries even further. Scientists can now decode the content of dreams using brain imaging, predict what people are dreaming about, and even influence dream content by playing specific sounds or odors during sleep. Some researchers are exploring whether it might be possible to enhance learning by manipulating sleep and dreams. The journey from ancient dream temples to modern sleep laboratories represents one of humanity's greatest intellectual adventures. What began as supernatural mystery has become cutting-edge neuroscience. Yet dreams remain as fascinating and essential as they were to our ancestors. Each discovery reveals new layers of complexity in the nightly journey your brain takes while you rest. The scientists who dedicate their careers to understanding sleep and dreams are driven by the same sense of wonder that motivated ancient dream interpreters. They recognize that in understanding dreams, we're not just learning about a biological process, but exploring the very nature of consciousness, creativity, and what it means to be human. Even with all our scientific advances, with brain scanners that can peer into the depths of the sleeping mind and computers that can decode dream content, the deepest questions about dreams remain beautifully, mysteriously unanswered. These aren't just gaps in our knowledge waiting to be filled by the next research study. They're profound mysteries that touch on the very nature of consciousness, reality, and human experience. Consider this puzzling question that has baffled scientists for decades. Why are dreams so consistently bizarre and illogical? Your dreaming mind regularly accepts scenarios that would immediately strike your waking consciousness as impossible. You might dream of having a conversation with your deceased grandmother in a house that's simultaneously your childhood home and your current workplace, while flying through rooms that change their architecture mid-flight. During the dream, none of this seems strange. It's only when you wake up that the logical impossibilities become apparent. This isn't a bug in the system. It's a feature, but scientists still can't fully explain why. Some researchers believe that the illogical nature of dreams serves a purpose in creative problem solving. By removing the constraints of logical thinking, your dreaming mind can make connections and explore solutions that your rational mind would immediately dismiss. The bizarre combinations of people, places, and scenarios in dreams might be your brain's way of stress testing ideas and exploring possibilities without the limitations of physical reality. But this raises another mystery. If dreams are supposed to help with problem solving and memory consolidation, why don't we remember most of them? The average person forgets over 90% of their dreams within minutes of waking up. This seems like a tremendous waste of mental effort. Your brain spends hours each night creating elaborate narratives, processing emotions, and exploring scenarios, only to have most of this work disappear like morning mist. Some scientists propose that forgetting dreams is actually adaptive. If you remembered every dream as vividly as waking memories, you might have difficulty distinguishing between real experiences and dream experiences. Imagine if you could recall, with perfect clarity, every conversation you've had with dream characters, every impossible place you've visited, every impossible thing you've done while asleep. Your sense of reality might become hopelessly confused. Yet this explanation raises its own questions. Why do some dreams remain vivid and memorable for years, even decades, while others vanish immediately? What determines which dreams your mind decides are worth remembering? Is there some unconscious filtering system that decides which dream experiences deserve permanent storage in your memory banks? The timing of dreams presents another puzzle that scientists are still working to solve. Why do your most vivid, emotionally intense dreams occur in the early morning hours, just before you wake up? From an evolutionary perspective, this seems counterintuitive. Early morning was traditionally when our ancestors would have been most vulnerable to predators. Why would the brain choose this time for its most elaborate dream productions? Some researchers suggest that morning dreams serve a unique function in preparing you for the coming day. Perhaps your brain uses these final dreams to integrate the memory processing that occurred during the night, and to mentally rehearse scenarios you might encounter when you wake up. But this is still largely speculation. The relationship between dream timing and dream function remains one of sleep science's unsolved mysteries. An even deeper mystery surrounds the subjective experience of dreaming itself. When you're dreaming, where exactly is your sense of self located? You typically experience dreams from a first-person perspective, as if you're the protagonist of the dream story. But sometimes you might observe yourself from outside, like watching a movie of your own life. Occasionally, you might be aware that you're dreaming while still remaining in the dream state, a phenomenon known as lucid dreaming. This fluidity of perspective and consciousness during dreams challenges our basic assumptions about the nature of self-awareness. If your sense of self can shift and change so dramatically during dreams, what does this tell us about consciousness during waking life? Are we more multiple, more fluid, more constructed than we usually realize? The mystery deepens when we consider that your dreaming brain creates not just visual experiences, but full sensory worlds. You can taste food in dreams, feel textures, hear music, and experience physical sensations. Some people even report smelling scents in their dreams. Your brain is somehow generating these sensory experiences without any input from your actual senses. The visual cortex creates sights without light reaching your eyes. The auditory cortex creates sounds without vibrations reaching your ears. How does the brain accomplish this remarkable feat? We know which brain regions are active during different types of dream experiences, but we still don't understand the mechanism by which neural activity transforms into subjective, conscious experience. This is part of what philosophers call the hard problem of consciousness, and dreams make this problem even more complex. Dreams also raise fascinating questions about the nature of time and narrative. Why does your dreaming mind create stories with beginnings, middles, and ends? Why not just random sequences of images or sensations? Your brain somehow constructs coherent narratives during dreams, complete with character development, plot progression, and emotional arcs. This suggests that storytelling isn't just something humans do when they're awake. It's a fundamental feature of how our minds organize experience. But the stories your dreaming mind tells don't follow the same rules as waking narratives. Dream time can compress, expand, or loop back on itself. You might experience years of dream time in minutes of real time, or have dreams that seem to last only seconds but feel emotionally significant. Some people report dreams where they live entire lifetimes, complete with relationships, careers, and aging, only to wake up and realize that decades of subjective experience occurred during a single night's sleep. Recent research has revealed another layer of mystery around the social aspects of dreams. Your dreams are populated with people, some you know and some you don't, some who exist and some who seem to be purely products of your imagination. These dream characters often behave in ways that surprise the dreaming mind, suggesting that your brain is creating autonomous agents within your dream world. Where do these dream characters come from? How does your mind generate personalities, behaviors, and dialogue for these dream people? Some neuroscientists propose that dream characters are constructed from memories of real people, combined and recombined in novel ways. Others suggest that they might represent different aspects of your own personality, various parts of yourself engaged in internal dialogue. But perhaps the deepest mystery of all is why we dream in the first place. Despite decades of research, scientists still debate the fundamental purpose of dreaming. We know that REM sleep is essential for memory consolidation, emotional processing, and learning. We know that dream deprivation leads to cognitive and emotional problems, but we still don't fully understand why this process requires the elaborate story-like experiences we call dreams. Some researchers propose that dreams are simply the subjective experience of memory consolidation, the conscious awareness of otherwise unconscious neural processes. In this view, dreams are like the screensaver on a computer, a visible manifestation of background processing that doesn't serve any additional function beyond the underlying neural work. Others argue that the narrative, experiential quality of dreams serves a crucial purpose in human cognition. Perhaps the act of experiencing dream scenarios, of feeling dream emotions, of navigating dream challenges, provides a kind of training that purely unconscious memory processing couldn't accomplish. Maybe consciousness itself, even dream consciousness, adds something essential to the learning process. There's something deeply humbling about these persistent mysteries. Here we are, in an age of unprecedented scientific knowledge, able to peer into the working brain with incredible precision. Yet the nightly journey of consciousness remains partly beyond our understanding. Every night, you participate in a process that connects you to the deepest questions about mind, reality, and human nature. As you settle into sleep tonight, you're not just resting your body or even just processing memories. You're entering a state of consciousness that philosophers and scientists have puzzled over for centuries. You're participating in a mystery that's as old as human awareness itself, yet as immediate and personal as your own breathing. The fact that we don't understand everything about dreams doesn't diminish their wonder. If anything, it enhances it. In a world where so much has been explained, categorized, and understood, dreams remain a frontier of mystery. They remind us that consciousness itself, the very thing that makes us who we are, still holds secrets that science is only beginning to uncover. Your mind, resting quietly on your pillow, will soon embark on adventures that no external observer can fully map or predict. The dreams you'll have tonight are yours alone, created by the unique constellation of your memories, emotions, and experiences. They're simultaneously the most private and most universal human experience, connecting you to everyone who has ever slept and dreamed, while remaining utterly individual and unrepeatable. Tonight, as you drift towards sleep, you're approaching not just rest, but mystery. The boundary between waking and dreaming is also the boundary between the known and the unknown, between scientific understanding and wonder that remains beautifully, mysteriously intact. Understanding the science of dreams isn't just fascinating. From an intellectual perspective, it can actually transform how you experience sleep and improve your waking life in ways that might surprise you. The quality of your dreams directly influences your mood, creativity, memory, and emotional resilience the next day. When you understand how this process works, you can begin to support and optimize it naturally. Your dream sleep affects everything, from your ability to solve problems to your capacity to regulate emotions. People who get quality REM sleep consistently show better performance on creative tasks, improved emotional stability, and enhanced ability to learn new information. This isn't just correlation, it's causation. The dreaming process literally reorganizes your brain in ways that make you more effective, more resilient, and more emotionally balanced when you're awake. Consider how dreams affect your emotional life. During REM sleep, your brain processes emotional experiences from the day, integrating them with your existing emotional memories and helping you develop more mature responses to challenging situations. This is why you might go to bed feeling overwhelmed by a problem and wake up with a clearer perspective on how to handle it. Your dreaming brain has been working on the emotional complexity of the situation while you rested. The memory benefits of quality dream sleep are equally remarkable. Your brain doesn't just passively store memories during sleep, it actively improves them. Information you learned during the day gets strengthened, irrelevant details get filtered out, and connections between different pieces of knowledge get enhanced. Students who sleep well after studying typically perform better on tests than those who stay up all night cramming, even though the sleep group spent fewer hours actively reviewing the material. This memory consolidation process explains why you sometimes wake up with solutions to problems that seemed impossible the day before. Your dreaming brain has access to your entire library of knowledge and experience, and it can make connections that your focused, logical waking mind might miss. The relaxed, associative thinking of dreams allows for the kind of creative problem-solving that leads to breakthrough insights. But here's what's particularly important to understand about supporting your dream sleep. You don't need expensive equipment, complicated routines, or dramatic lifestyle changes. Your brain already knows how to dream effectively. What it needs is the right conditions to do what it does naturally. The foundation of quality dream sleep is consistency. Your brain's internal clock, your circadian rhythm, thrives on predictability, going to bed and waking up at roughly the same time each day, even on weekends, helps synchronize all the complex biological processes that support healthy sleep cycles. This doesn't mean you need to be rigid about timing, but having a general rhythm helps your brain prepare for the different stages of sleep. Your sleep environment plays a crucial role in dream quality. Cool temperatures, typically between 6 and 68 degrees Fahrenheit, help facilitate the deep sleep stages that set up quality REM periods later in the night. Darkness signals your brain to produce melatonin, the hormone that promotes sleep onset. Even small amounts of light from electronic devices can disrupt this process. so creating a truly dark sleeping environment supports your natural sleep chemistry. The quality of your mattress and pillows affects not just your comfort, but your sleep architecture. When you're physically comfortable, you spend less time in light sleep stages and more time in the deeper, more restorative phases. This means more efficient memory consolidation and more vivid, memorable dreams. What you do in the hour before bed significantly impacts your dream sleep. Your brain needs time to transition from the alertness of daytime activities to the receptive state that allows for quality sleep. Activities that promote this transition include reading, gentle stretching, listening to calming music, or practicing relaxation techniques. The key is finding activities that help your mind shift from the external focus of daytime to the internal focus that facilitates sleep. Avoiding stimulating activities before bed isn't just about caffeine, though limiting caffeine after 2 p.m. does support better sleep for most people. It's also about mental stimulation. Intense conversations, exciting movies, or stressful work tasks close to bedtime can keep your mind in an alert state that interferes with the natural progression into sleep stages. Exercise supports dream sleep, but timing matters. Regular physical activity improves sleep quality and increases the amount of time you spend in deep sleep stages. However, vigorous exercise within 3 hours of bedtime can be stimulating and make it harder to fall asleep. The ideal timing for exercise is earlier in the day, when it can help regulate your circadian rhythm and build the healthy fatigue that promotes quality sleep. Nutrition also plays a role in dream sleep quality. Large meals close to bedtime can disrupt sleep because your digestive system needs to work when it's expecting to rest. But going to bed hungry can also interfere with sleep. A light snack that includes some protein and complex carbohydrates eaten an hour or two before bed can actually support stable blood sugar levels throughout the night and promote uninterrupted sleep. Alcohol deserves special mention because its effects on sleep are often misunderstood. While alcohol can make you feel drowsy and help you fall asleep faster, it significantly disrupts REM sleep later in the night. People who drink alcohol before bed typically experience fragmented sleep with reduced dream periods. This is why you might feel unrested even after a full night's sleep following alcohol consumption. One of the most powerful tools for appreciating and benefiting from your dreams is keeping a dream journal. This practice doesn't require any special equipment, just a notebook and pen beside your bed. The simple act of writing down whatever you remember from your dreams, even if it's just fragments or emotions, can dramatically improve your dream recall over time. Dream journaling works because it signals to your brain that dreams are important and worth remembering. Many people who start keeping dream journals are amazed to discover how much they were dreaming but simply forgetting upon waking. As your recall improves, you might begin to notice patterns in your dreams, recurring themes or characters that reflect what's happening in your waking life. The timing of when you wake up can also affect how well you remember dreams. Since your most vivid dreams occur during REM periods, and these cluster toward the end of the night, waking up naturally, rather than with an alarm, often results in better dream recall. If you must use an alarm, try to set it for a time that allows for complete sleep cycles, typically in increments of 90 minutes from when you fall asleep. Some people find that certain foods or supplements support their dream experiences. Foods rich in vitamin B6, such as bananas, fish, or chickpeas, are sometimes associated with more vivid dreams. Melatonin supplements can help with sleep onset, but should be used carefully and preferably under medical guidance. as the timing and dosage need to be precisely matched to your individual circadian rhythm. The most important thing to remember about supporting your dream sleep is that small, consistent changes are more effective than dramatic overhauls. Your brain is remarkably adaptable, and it will respond to gentle, sustained improvements in your sleep habits. The goal isn't to control or manipulate your dreams, but to create the optimal conditions for your brain to do what it does naturally. Quality dream sleep isn't a luxury. It's a fundamental requirement for optimal mental and emotional functioning. When you prioritize the conditions that support healthy dreaming, you're investing in your creativity, emotional resilience, memory, and overall well-being. You're also honoring one of the most remarkable capabilities of your brain, its ability to create meaning, process, experience, and solve problems while you rest. Tonight, as you prepare for sleep, remember that you're not just ending your day. You're beginning an important phase of mental and emotional restoration. The dreams you'll experience are your brain's gift to itself, a nightly renewal that prepares you for whatever tomorrow might bring. When you dream tonight, you'll be participating in a biological ritual that extends far beyond your individual experience. Dreams connect you to patterns that span across species, across evolutionary time, and across the fundamental processes that organize life on Earth. Understanding these broader connections reveals that your nightly journey into dream consciousness isn't just a personal experience, it's part of something much larger and more profound. Every mammal on Earth dreams. From the tiniest shrew to the largest whale, from house cats to elephants. All warm-blooded animals show the characteristic brainwave patterns of REM sleep. This universality suggests that dreaming evolved hundreds of millions of years ago, long before humans developed language, culture, or self-awareness. The fact that evolution has preserved this apparently vulnerable state across countless species and countless generations indicates that dreaming serves functions so fundamental that no mammalian brain can survive without it. Birds also dream, though their REM patterns are different from mammals. Scientists have observed sleeping birds showing the same rapid eye movements and similar brain activity patterns. Even more remarkably, researchers have recorded the brain activity of sleeping zebra finches and found that the neural patterns from learning new songs during the day are replayed during sleep. The birds are literally practicing their songs in their dreams, perfecting the melodies they learned while awake. This cross-species perspective on dreaming reveals something profound about the nature of consciousness itself. Dreaming isn't uniquely human, it's a fundamental feature of complex nervous systems. This suggests that consciousness, the subjective experience of being aware, might be far more widespread in the animal kingdom than we typically assume. When your dog twitches and whimpers during sleep, she might be experiencing something remarkably similar to your own dream adventures. The evolutionary persistence of dreaming becomes even more fascinating when you consider the apparent costs and risks involved. During REM sleep, mammals are essentially paralyzed and highly vulnerable to predation. An animal in REM sleep shows little response to external threats. From a survival perspective, this seems like a dangerous liability. Yet evolution not only preserved this vulnerable state, but actually increased the amount of time spent in REM sleep as mammals became more cognitively complex. This suggests that the benefits of dreaming must outweigh even the significant survival costs. What could be so important that evolution would risk the lives of countless animals to preserve it? The answer seems to be related to the sophisticated behavioral flexibility that complex brains make possible. Animals with larger, more complex brains spend more time in REM sleep, suggesting that dreaming is somehow essential for the advanced cognitive abilities that these brains provide. The connection between dreaming and cognitive complexity becomes clearer when you consider what happens to animals deprived of REM sleep. They show deficits in learning, memory formation, and emotional regulation that are remarkably similar to what happens in humans. This suggests that the fundamental functions of dreaming, memory consolidation, emotional processing, and creative problem solving are shared across many species. Your dreams also connect you to the deepest rhythms of life on Earth. The sleep-wake cycle is synchronized with the planet's rotation, connecting your personal circadian rhythm to the cosmic rhythm of day and night. This isn't just poetic metaphor, it's biological reality. The same light-dark cycle that governs the blooming of flowers and the migration of birds also regulates the complex neurochemical processes that create your dreams. This connection to natural rhythms explains why modern life, with its artificial lighting and irregular schedules, can disrupt sleep and dreaming so profoundly. Your brain evolved to synchronize with natural light cycles, and when these rhythms are disrupted, the intricate timing of sleep stages can become disordered. This is why shift workers often experience sleep difficulties, and why traveling across time zones creates jet lag that affects not just alertness but dream quality as well. The seasonal variations in daylight also affect dreaming patterns. People living in northern latitudes often experience changes in sleep and dream patterns during the long darkness of winter months. Some researchers suggest that the increased dreaming during longer nights might serve a function in processing the emotional challenges of winter survival, helping our ancestors cope with the psychological stress of cold, dark months. The social implications of dreaming reveal another layer of connection that spans across human cultures and throughout history. Every known human culture has developed beliefs, rituals, and practices around dreams. This universality suggests that dreaming has been recognized as significant by humans wherever and whenever they've lived. The content and interpretation of dreams varies dramatically across cultures, but the recognition of dreams as meaningful experiences is universal. Some cultures consider dreams to be as real and important as waking experiences. The Aboriginal Australian concept of the dream time describes a parallel reality that's accessed through dreams and that connects the present to the ancestral past and future. Many Native American traditions include dream sharing as a central part of community life, with important dreams being discussed and interpreted collectively. These cultural perspectives on dreams reveal something important about the relationship between individual consciousness and collective human experience. While each person's dreams are uniquely their own, the act of dreaming connects us to shared human experiences of meaning-making, storytelling, and symbolic thinking. The characters, scenarios, and emotions that populate your dreams often reflect not just your personal experiences, but also the broader cultural narratives and archetypal patterns that shape human understanding. The therapeutic implications of understanding dreams extend far beyond individual sleep improvement. Mental health professionals are increasingly recognizing that dream quality is both an indicator and a determinant of psychological well-being. People experiencing depression often show disrupted REM sleep patterns, and improving sleep quality can significantly impact mood and emotional resilience. Trauma processing through dreams is an area of intense current research. Evidence suggests that REM sleep plays a crucial role in helping the brain integrate traumatic experiences in a way that reduces their emotional impact over time. This is why sleep disturbances are often a central feature of post-traumatic stress disorder, and why improving sleep quality is often an important component of trauma therapy. The connection between dreams and creativity has implications that extend into education, business, and artistic endeavors. Understanding how the dreaming brain makes novel connections and generates creative solutions could inform approaches to problem-solving and innovation in many fields. Some companies are already experimenting with nap policies and sleep optimization programs as ways to enhance employee creativity and productivity. Looking toward the future, the broader implications of dream research are staggering. As we develop better technologies for monitoring and even influencing dreams, we might be able to enhance learning, accelerate recovery from trauma, or augment creative problem-solving. The possibility of shared dreaming experiences, dream recording, or dream communication represents a frontier that could transform human consciousness in ways we can barely imagine. But perhaps the most profound implication of understanding dreams is what it reveals about the nature of consciousness itself. Dreams demonstrate that consciousness isn't a simple on-off switch, but a complex, multifaceted phenomenon with many different states and qualities. The fluid, creative, emotionally rich consciousness of dreams shows us capabilities of mind that are often overshadowed by the focused, logical consciousness of waking life. This broader perspective on consciousness suggests that humans might be capable of ways of thinking and experiencing that we've barely begun to explore. If the dreaming mind can solve problems that the waking mind cannot, make connections that logical thinking misses, and experience realities that feel completely convincing, what other capabilities might consciousness possess? Your dreams connect you not just to your own inner life, but to the vast web of life on Earth, to the cosmic rhythms that govern planetary existence, to the shared human journey of meaning and understanding, and to the deepest mysteries of consciousness itself. When you dream tonight, you're participating in processes that are simultaneously deeply personal and utterly universal, connecting your individual experience to patterns that span across space and time. This understanding transforms dreams from mere curiosities or biological necessities into windows into the fundamental nature of life, consciousness, and human potential. Your nightly journey into dream consciousness isn't just rest and restoration. It's participation in one of the most profound and mysterious aspects of existence itself, the frontier of dream. Research is advancing so rapidly that what seemed like science fiction just a decade ago is now happening in laboratories around the world. Scientists can now peer into sleeping brains with unprecedented precision, decode the content of dreams, and even influence what people dream about. These breakthroughs are not just advancing our understanding of sleep and consciousness. They're opening possibilities that could transform human experience in ways we're only beginning to imagine. In laboratories at ATR in Japan, researchers have developed technology that can predict what people are dreaming about by analyzing their brain scans in real time. Using sophisticated machine learning algorithms trained on thousands of hours of brain imaging data, they can determine whether a sleeping person is dreaming about faces, words, colors, or specific objects. The accuracy is still limited, but the fact that it's possible at all represents a stunning achievement in neuroscience. The implications of being able to read dreams are staggering. Imagine if we could help people who have lost the ability to communicate due to stroke or other brain injuries by accessing their dream content. Or consider the potential for understanding the unconscious thought processes that influence our waking decisions and behaviors. Dream reading technology might eventually allow us to access layers of mental activity that are normally completely private and invisible. But scientists aren't just reading dreams, they're learning to influence them. Targeted memory reactivation is a technique where researchers play specific sounds or odors during sleep to influence which memories get strengthened and which dreams occur. If you learn a new skill while listening to a particular piece of music, playing that same music during your sleep can enhance the learning process and even influence your dreams to include practice sessions with that skill. This technique has already shown remarkable results in learning enhancement. Students who listen to specific sounds while studying, then hear those same sounds during sleep, show significantly improved performance on tests the next day. Musicians who practice pieces while associated with particular scents, then experience those scents during sleep, wake up with improved musical abilities. The sleeping brain is essentially continuing the learning process, guided by these subtle environmental cues. Lucid dreaming research is revealing even more extraordinary possibilities. Lucid dreaming occurs when you become aware that you're dreaming, while still remaining in the dream state. This awareness allows some people to actually control their dream experiences, choosing where to go, what to do, and how the dream narrative unfolds. While only about 20% of people naturally experience lucid dreams regularly, researchers are developing techniques to increase the frequency and controllability of these experiences. Dr. Stephen Bobberg at Stanford University pioneered much of this research, developing methods for training people to recognize when they're dreaming and maintain awareness within the dream state. More recently, researchers have experimented with devices that detect REM sleep and provide subtle cues, such as gentle light flashes or sounds, that can trigger lucid awareness without waking the dreamer. The potential applications of controllable lucid dreaming are remarkable. People could use lucid dreams to practice skills, rehearse challenging scenarios, overcome fears and phobias, or explore creative possibilities in a completely safe environment. Athletes could practice their sports in dreams where they have unlimited opportunities to perfect their technique. Artists could explore creative ideas in dream worlds where the laws of physics don't apply. Nightmare therapy represents another promising application of dream intervention techniques. Researchers are developing methods for helping people who suffer from chronic nightmares to gain control over their dream experiences. Image rehearsal therapy involves teaching people to reimagine their nightmares while awake, creating alternative endings or scenarios. When combined with lucid dreaming training, this can allow people to transform frightening dreams into more positive experiences. For people suffering from PTSD, who often experience recurring traumatic nightmares, these techniques could be life-changing. Instead of being helpless victims of their dream experiences, they could learn to take control and create healing, empowering dream narratives. Early trials of these approaches have shown promising results, with significant reductions in nightmare frequency and improvements in overall sleep quality. Brain stimulation during sleep is another frontier that's showing remarkable promise. Transcranial stimulation techniques can enhance specific brain waves during sleep, potentially improving memory consolidation, increasing creativity, or reducing symptoms of depression. Some researchers are experimenting with precisely timed electrical stimulation that enhances the slow waves of deep sleep, leading to better memory formation and more restorative sleep. The timing of these interventions is crucial. The brain moves through its sleep stages in precisely orchestrated cycles, and interventions must be timed to work with, rather than against, these natural rhythms. Advanced monitoring systems can now detect the exact moment when the brain enters specific sleep stages, allowing for interventions that are perfectly synchronized with the brain's natural processes. Artificial intelligence is revolutionizing dream research in ways that seemed impossible just a few years ago. Machine learning algorithms can now analyze patterns in dream reports, brain imaging data, and sleep recordings to identify correlations and predictions that human researchers might miss. AI systems are discovering connections between dream content and waking life events, between sleep patterns and mental health outcomes, and between individual differences in dreaming and cognitive abilities. These AI analyzers are revealing that dreams are far more organized and meaningful than was previously understood. Rather than being random neural noise, dreams appear to follow complex patterns related to memory processing, emotional regulation, and creative problem solving. The dreaming brain seems to be running sophisticated simulations, testing scenarios, and exploring possibilities in ways that are only now becoming visible through advanced computational analysis. Pharmaceutical approaches to dream enhancement are also advancing rapidly. Researchers are developing compounds that can selectively enhance specific stages of sleep or influence particular aspects of dream content. These aren't sleeping pills, but precision tools that could optimize the brain's natural sleep and dreaming processes. Some experimental medications can increase the vividness of dreams, enhance memory consolidation during sleep, or reduce the emotional intensity of nightmares. The development of these pharmacological tools raises important ethical questions about the enhancement of natural brain functions. If we can make dreams more vivid, learning more efficient, or emotional processing more effective, should we? What are the potential risks and unintended consequences of intervening in processes that have been shaped by millions of years of evolution? Virtual reality technology is beginning to merge with dream research in fascinating ways. Researchers are developing VR systems that can be synchronized with sleep stages, providing visual and auditory experiences that can influence dream content. Some experimental systems allow people to experience VR scenarios just before sleep, which then influence the content and narrative structure of their subsequent dreams. The possibility of shared dreaming experiences represents perhaps the most speculative but intriguing frontier of dream research. If we can read and influence dreams, could we eventually allow multiple people to share the same dream space? Some researchers are exploring whether it might be possible to create communication channels between dreaming minds, allowing for shared adventures or collaborative problem-solving in dream states. Looking further into the future, the convergence of neurotechnology, artificial intelligence, and our growing understanding of consciousness could lead to possibilities that seem almost magical. Dream recording and playback, direct brain-to-brain communication during sleep, or the ability to download specific skills or knowledge during dreams all remain in the realm of speculation. But they're no longer completely beyond the bounds of scientific possibility. The clinical applications of advanced dream research could transform medicine and mental health treatment. Instead of relying solely on medications or therapy during waking hours, we might be able to use the 8 hours of sleep as an active treatment period. Sleep could become a time for accelerated learning, emotional healing, creative problem solving, and neural repair. Educational applications are equally exciting. If we can enhance learning and memory consolidation during sleep, the traditional model of education could be revolutionized. Students might be able to master complex subjects more quickly and retain information more effectively by optimizing their sleep and dreaming processes. The phrase "sleep on it" might take on literal significance. As we learn to use dreams as active learning environments, but perhaps the most profound implications of cutting-edge dream research relate to our understanding of consciousness itself. As we develop technologies that can read, influence, and potentially share dreams, we're forced to confront fundamental questions about the nature of subjective experience, the boundaries of individual consciousness, and the relationship between mind and brain. These advances in dream research are happening now, in laboratories around the world, pushing the boundaries of what we thought possible about sleep, consciousness, and human potential. The technologies and techniques being developed today will likely transform how future generations experience sleep, learning, healing, and perhaps consciousness itself. The dreaming brain, once considered mysterious and inaccessible, is becoming a new frontier for human enhancement and understanding. Your dreams tonight are not just personal experiences, but participation in a realm that science is just beginning to explore, and that holds possibilities we can barely imagine. As we journey deeper into understanding the science of dreams, something profound begins to emerge about what this knowledge means for you personally. This isn't just abstract scientific information. It's insight into one of the most intimate and essential aspects of your daily existence. Every night of your life, you participate in a process that's simultaneously utterly personal and completely universal, connecting you to the deepest mysteries of human consciousness, while creating experiences that are uniquely and irreplaceably yours. Think about this remarkable fact. In your lifetime, you'll have approximately 150,000 individual dreams. Each one will be a unique creation of your mind, a one-time performance in the theater of your consciousness that will never be exactly repeated. No other person in the history of humanity has ever had, or ever will have, the precise dreams that you experience. They emerge from the specific constellation of your memories, emotions, relationships, hopes, fears, and experiences. Your dreams are as individual as your fingerprints, as personal as your heartbeat. Yet this most private of experiences connects you to something universal. When you dream tonight, you'll join billions of other sleeping minds around the world, each creating their own inner universes, each processing the day's experiences, each weaving the threads of memory and emotion into the fabric of consciousness. In cities and villages, in every time zone, as darkness falls, human brains enter the same mysterious state, following rhythms that have pulsed through our species for hundreds of thousands of years. This perspective can transform how you understand your own dreams, even the strange, fragmentary, or seemingly meaningless ones. Every dream, no matter how bizarre or fleeting, represents your brain's attempt to make sense of your experience, to integrate new information with old, to process emotions that might be too complex for waking consciousness to handle directly. When you dream about impossible scenarios, talking animals, or situations that defy logic, your mind isn't malfunctioning, it's engaging in the kind of creative, associative thinking that can lead to insights and understanding that linear, logical thought might never achieve. The emotional content of your dreams deserves particular attention and respect. Dreams often involve intense feelings, from joy and love to fear and sadness. These emotional experiences aren't just random firings of neural circuits. They're your brain's way of processing and integrating the emotional complexity of your waking life. When you have a dream that leaves you feeling peaceful, excited, or even unsettled, your emotional system has been working through something important. even if you can't immediately understand what it was. Anxiety dreams, for instance, often reflect your brain's attempt to prepare for challenges or process worries that you might not even be consciously aware of. Rather than seeing these as negative experiences, you can understand them as your mind's way of rehearsing responses to potential difficulties, building emotional resilience, and working through concerns that need attention. Your dreaming brain is like a caring friend who stays up all night, helping you prepare for life's challenges. The creative insights that emerge from dreams reveal something beautiful about the nature of your mind. When you wake up with a solution to a problem, a new perspective on a relationship, or an idea for a creative project, you're experiencing the fruits of your brain's nightly creativity session. Your dreaming mind has access to your entire lifetime of knowledge and experience, and it can combine this information in ways that your focused, conscious thinking might never attempt. This creative capacity of dreams suggests that you possess resources and capabilities that extend far beyond what you can access during normal waking consciousness. Your mind is more creative, more insightful, and more capable of making meaningful connections than you might realize. Dreams are windows into these hidden capacities, glimpses of your mind's full potential. The fact that you forget most of your dreams doesn't diminish their value or importance. The processing that occurs during dreams benefits you whether you remember the specific content or not. The memory consolidation, emotional integration, and creative connections happen at levels below conscious awareness. You wake up changed by your dreams, even when you can't recall them. The person who gets out of bed in the morning has been shaped by the night's dreaming, made a little bit different, a little bit more integrated, a little bit more prepared for the day ahead. As you prepare for sleep tonight, you can approach it with a sense of anticipation and appreciation. You're not just ending your day, you're preparing to enter a realm of experience that's uniquely yours, where your mind will work on your behalf in ways that are both mysterious and essential. The dreams you'll have tonight are gifts from your own consciousness to yourself, experiences that will contribute to your growth, healing, and understanding in ways that you might never fully comprehend, but will certainly benefit from. Your dreaming mind is one of your most loyal and tireless companions, working every night to help you process, experience, solve problems, and prepare for whatever tomorrow might bring. It deserves recognition, appreciation, and the kind of care that allows it to do its work most effectively. When you create conditions that support quality sleep and dreaming, you're honoring this remarkable capacity of your consciousness and investing in your own well-being in the most fundamental way possible. This transformation reveals something profound about the nature of your mind itself. You're not just one type of consciousness wearing different masks. You're truly multiple forms of awareness contained within a single brain. The logical, analytical consciousness that handles daily challenges coexists with the creative, emotional consciousness that constructs dream narratives. The focused awareness that solves practical problems shares neural space with the expansive awareness that can experience flying, time travel, and conversations with impossible beings. Understanding this multiplicity of consciousness within yourself can be deeply liberating. It means that when you feel stuck in logical thinking, unable to see creative solutions or new perspectives, you have access to other ways of processing information. Your dreaming mind isn't just a backup system that runs while your main consciousness is offline. It's an entirely different operating system with its own strengths, capabilities, and ways of understanding the world. The integration of memory, emotion, and creativity that occurs during dreams represents one of the most sophisticated information processing systems in the known universe. Your brain doesn't just store memories like a computer filing away data. It weaves them together with emotional significance, creative associations, and future possibilities. The dream about your childhood home populated with current colleagues isn't random. It's your mind exploring connections between past experiences and present relationships, finding patterns and meanings that might inform future decisions. This integrative process explains why dreams often feel meaningful even when they're logically impossible. Your dreaming brain is operating according to emotional and associative logic rather than factual logic. It connects things that feel related rather than things that are literally related. This type of thinking, which seems strange from a waking perspective, is actually incredibly valuable for understanding complex emotional situations, generating creative ideas, and making intuitive leaps that pure logic might miss. The cyclical nature of your nightly sleep journey reflects patterns that extend far beyond your individual experience. The 90-minute rhythm of your sleep cycles echoes in many other biological and psychological processes. Your attention span during waking hours follows similar cycles. Your creativity and energy levels fluctuate according to rhythms that mirror your sleep architecture. Even your social interactions and emotional states show patterns that reflect the same underlying biological rhythms that organize your dreams. This suggests that consciousness itself might be fundamentally rhythmic, moving in cycles between different modes of awareness, even during waking hours. The focused attention you bring to challenging tasks alternates naturally with the more relaxed, associative thinking that leads to creative insights. Understanding these rhythms can help you work with your natural cycles rather than against them, timing different types of activities to match your brain's natural fluctuations between different modes of consciousness. The evolutionary perspective on dreams reveals that this nightly transformation of consciousness has been preserved and refined across millions of years because it serves functions that are absolutely essential for complex life. Every mammal dreams because dreaming solves problems that no other biological process can handle. The vulnerability of REM sleep, the energy cost of maintaining high brain activity during rest, the complexity of the neurochemical orchestration required, all of this has been maintained by evolution because the benefits are so crucial. This evolutionary validation of dreaming can give you confidence in trusting your own dream processes. Your brain has been shaped by millions of years of natural selection to dream effectively. The strange, seemingly random nature of dreams isn't a flaw to be corrected, but a feature that has been optimized over evolutionary time. When your dreams feel confusing or illogical, it's because they're operating according to principles that have been tested and refined by countless generations of dreaming ancestors. The social and cultural universality of dream experiences points to something even deeper about human nature. Every culture in human history has recognized dreams as significant experiences worthy of attention, interpretation, and sometimes reverence. This universal recognition suggests that dreaming touches on something fundamental about what it means to be human. The specific interpretations vary dramatically across cultures, but the recognition that dreams matter is constant. This cultural universality of dream significance reveals that you're participating in one of the most fundamentally human experiences possible. When you dream, you're engaging in a form of consciousness that has shaped human culture, spirituality, art, and understanding throughout history. Your individual dreams connect you to the broader human story of meaning-making, symbol creation, and the search for understanding that transcends literal reality. The scientific understanding of dreams doesn't diminish their mystery or significance. It enhances it. Knowing that your brain can create vivid sensory experiences without sensory input, construct coherent narratives while logical thinking is offline, and solve problems through impossible scenarios doesn't explain away the wonder of these experiences. If anything, it makes them more remarkable. The fact that a biological system can create experiences that feel magical while serving practical functions, like memory consolidation and emotional processing, is perhaps the most beautiful example of nature's ingenuity. This integration of scientific understanding with personal meaning reflects a broader truth about consciousness itself. The more we learn about how the brain creates subjective experience, the more remarkable subjective experience becomes. Understanding the mechanisms behind dreams doesn't reduce them to mere mechanisms. It reveals the incredible sophistication required to create the rich, meaningful, emotionally significant experiences that fill your nights. The therapeutic implications of understanding dreams as integrated processing systems extend beyond just improving sleep quality. When you recognize that your dreams are actively working on your emotional well-being, relationship dynamics, creative challenges, and life decisions, you can approach them as allies in your personal growth, instead of seeing disturbing dreams as problems to be avoided. You can understand them as your mind's way of processing difficult material that needs attention. This perspective transforms your relationship with your entire sleep experience. Sleep becomes not just rest time, but processing time, integration time, growth time. The hours you spend unconscious become some of the most important hours for your psychological and emotional development. This understanding can motivate you to prioritize sleep, not just for physical health, but for mental and emotional well-being. The creative potential revealed by dream research has implications that extend into every area of human endeavor. Understanding how the dreaming mind makes novel connections, explores impossible scenarios, and generates unexpected solutions can inform approaches to innovation, problem-solving, and artistic creation. The boundary between sleeping and waking creativity becomes fluid when you understand that both draw from the same underlying capacity for making meaningful connections between disparate elements. This creative integration suggests that you have access to far more innovative potential than you might realize. The same mind that creates elaborate dream narratives every night has the capacity for creative problem-solving, artistic expression, and innovative thinking during waking hours. Learning to access and trust these creative capacities can transform how you approach challenges and opportunities in your daily life. The future possibilities revealed by cutting-edge dream research don't just promise technological advances. They suggest that human consciousness itself might be more malleable and expandable than we've previously understood. If we can learn to read dreams, influence their content, and potentially share dream experiences, we might be on the verge of discovering new modes of human consciousness that are currently unimaginable. But perhaps the most important integration that emerges from understanding the science of dreams is the recognition that your nightly journey into unconsciousness is actually a journey into a different, equally valid form of consciousness. Dreams aren't the absence of awareness, but the presence of a different kind of awareness. They're not a break from conscious experience, but a continuation of conscious experience, according to different rules and different possibilities. This understanding can transform how you think about the relationship between sleeping and waking life. Instead of seeing them as opposites, you can understand them as complementary aspects of a fuller, richer form of human consciousness. The person who analyzes problems during the day and the person who flies through impossible. Dreamscapes at night aren't different people. They're different expressions of your complete conscious being, the dance of science that we've explored throughout. This journey reveals something beautiful about how human knowledge grows and deepens. Our understanding of dreams has evolved from ancient supernatural explanations to modern neuroscience, yet each new discovery only deepens the mystery and wonder. This isn't a failure of science, it's one of its greatest triumphs. The fact that we can now monitor brainwaves, decode dream content, and influence dream experiences doesn't diminish the magic of dreaming. It reveals just how magical the everyday operation of consciousness truly is. The patterns we've discovered in dream research echo patterns found throughout nature and human experience. The cycles of sleep mirror the cycles of seasons, tides, and celestial movements. The creative connections made during dreams reflect the same processes that drive innovation, artistic expression, and scientific discovery during waking hours. The emotional processing that occurs during REM sleep follows principles that govern healing, growth, and adaptation throughout biology. This suggests that dreaming isn't an isolated phenomenon but part of a larger tapestry of natural processes that organize life, consciousness, and meaning. When you dream, you're participating in patterns that connect you to the fundamental rhythms that govern everything from cellular regeneration to cosmic cycles. Your individual consciousness becomes part of something much larger and more interconnected than you might normally perceive. As we prepare to conclude our exploration, there's something peaceful about recognizing that the mystery of dreams isn't a problem to be solved, but a wonder to be appreciated. The fact that consciousness can transform itself so completely each night, creating experiences that feel absolutely real while serving functions essential for health and well-being, speaks to capabilities of mind that we're only beginning to understand. The questions that remain unanswered about dreams aren't gaps in our knowledge waiting to be filled. They're invitations to continued wonder and exploration. Each discovery about the dreaming brain reveals new layers of complexity and new questions to explore. This ongoing mystery keeps the sense of wonder alive, reminding us that consciousness itself remains one of the most beautiful and profound aspects of existence. Tonight, when you enter sleep, you can carry with you an appreciation for the remarkable processes that will unfold in your sleeping mind. The dreams you'll experience are simultaneously the most scientifically studied and most personally mysterious aspects of human consciousness. They connect you to cutting-edge neuroscience and ancient human experience, to individual healing and universal patterns, to known mechanisms and enduring mysteries. There's something deeply comforting about this integration of knowledge and wonder. Understanding the science of dreams doesn't diminish their personal significance, it enhances it. Knowing that your dreaming brain is following precisely orchestrated biological processes while creating utterly unique personal experiences brings together the objective and subjective aspects of human existence in the most beautiful way possible. As your breathing begins to slow and your thoughts start to drift towards sleep, remember that you're approaching one of the most remarkable territories of human experience. The boundary between what we understand scientifically and what remains wonderfully mysterious is about to embrace you in the gentlest possible way as our gentle journey through the science of dreams draws to its peaceful close. Let's take a moment to appreciate the extraordinary territory we've explored together. We began in a basement laboratory in 1953, watching an 8-year-old boy's eyes move beneath closed lids. And we've traveled through the intricate mechanisms of sleep cycles, the vast scales of neural processing, the evolutionary history of dreaming consciousness, and the cutting-edge frontiers where science meets the deepest mysteries of human awareness. We've discovered that your brain doesn't simply power down when you close your eyes each night. Instead, it transforms into something entirely different. Something that creates vivid worlds populated with impossible characters and governed by dream logic that transcends every law of physical reality. We've learned that the 6 years you'll spend dreaming across your lifetime aren't time stolen from consciousness, but time spent in a different, equally valid form of consciousness, one that's absolutely essential for memory formation, creative problem-solving, emotional healing, and the very foundations of what makes you uniquely human. Together, we've witnessed how your sleeping brain becomes the ultimate storyteller, weaving together memories from across your entire lifetime with emotions from your deepest experiences and creative possibilities that your logical waking mind might never dare to consider. Every single night, your consciousness embarks on adventures that feel completely real while following rules that would be impossible in any waking state. You soar through landscapes that exist nowhere but in the theater of your mind, engage in conversations with people who live only in your dreams, and experience emotions and scenarios that prepare you for challenges and opportunities you haven't yet encountered. The science has revealed that these nightly adventures aren't just random neural static or meaningless side effects of brain maintenance. Your dreams are carefully constructed experiences created by the most sophisticated information processing system in the known universe. Your brain harnesses 100 billion neurons, deploying more raw computing power than the most advanced supercomputers ever built, to craft these nocturnal narratives that feel as authentic as any waking experience, while serving functions that are absolutely crucial for your mental, emotional, and even physical well-being. We've discovered that dreaming connects you to evolutionary patterns that span hundreds of millions of years, to biological rhythms that synchronize with the very rotation of our planet, and to creative processes that have inspired humanity's greatest discoveries, artistic masterpieces, and breakthrough innovations. When you dream tonight, you'll participate in a form of consciousness that's simultaneously utterly personal and completely universal, connecting your individual inner experience to the broader patterns that organize life, awareness, meaning, and the mysterious dance of existence itself. The deeper mysteries we've explored together remind us that even with all our remarkable scientific advances, consciousness itself remains beautifully, mysteriously, wonderfully incomplete in our understanding. The fact that your brain can create entire sensory worlds without any external input, construct coherent narratives while logical thinking is completely offline, and generate elegant solutions to complex problems through pure imagination speaks to capabilities of mind that science is only beginning to glimpse and appreciate. Yet this incomplete understanding doesn't diminish the wonder of dreams in any way. If anything, it enhances their magic exponentially. In our modern world, where so much has been explained, categorized, and reduced to formulas, your nightly journey into dream consciousness remains a pristine frontier of mystery and infinite possibility. Each dream you experience is a unique creation that has never existed before in the history of the universe and will never be repeated exactly. A one-time only performance in the grand theater of your personal consciousness. The practical insights we've shared about supporting your dream sleep can certainly improve how you rest. But more importantly, they can transform how you understand and appreciate yourself. Recognizing that your dreaming mind works tirelessly on your behalf every single night, processing complex emotions, consolidating precious memories, solving intricate problems, and preparing you for tomorrow's challenges can bring a profound sense of gratitude and appreciation for the wisdom and care that's built into the very architecture of your consciousness tonight. As you begin to settle into sleep, you can approach this transition not merely as the end of another day, but as the beginning of one of the most important phases of mental and emotional restoration your body and mind will experience. Your brain will gracefully cycle through its carefully orchestrated stages, each one serving specific functions that contribute to your health, your resilience, your creativity, and your capacity for continued growth and adaptation. The deep sleep stages will gently cleanse your neural networks of the day's accumulated metabolic waste and consolidate the most important memories from your experiences. Meanwhile, the REM periods will carefully integrate emotional experiences that need processing and provide the creative, problem-solving benefits that make dreams such an essential component of human consciousness. You can trust this ancient process completely and without reservation. Your brain already knows exactly how to sleep and dream with perfect effectiveness, requiring no conscious effort or intervention from you whatsoever. The same evolutionary wisdom that regulates your heartbeat and coordinates your breathing also orchestrates the intricate neurochemical symphony that creates healthy, restorative sleep cycles. This remarkable system has been refined and perfected across millions of years of natural selection to serve your deepest needs with extraordinary precision and care. As your breathing naturally begins to deepen and your thoughts start to drift like clouds across a peaceful sky, remember that you're approaching one of the most remarkable capabilities of human consciousness. The boundary between waking and sleeping isn't a solid wall, but a gentle doorway, a graceful transition from one beautiful form of awareness to another equally valid and meaningful form. Your consciousness isn't disappearing as you fall asleep. It's simply transforming into something equally real, but operating according to entirely different and wonderfully mysterious principles. The dreams you'll experience tonight are precious, gifts from your own mind to itself, experiences that will contribute to your understanding, your creativity, your emotional balance, and your overall well-being in ways that are both scientifically demonstrable and personally mysterious. Whether you remember these dreams in vivid detail or they fade like morning mist, they will change you in subtle but meaningful ways. Integrating today's experiences with your lifetime treasury of memories, processing emotions that need gentle attention, and perhaps providing insights that will emerge in your waking consciousness tomorrow or in days to come. Your sleeping brain will join the nightly communion of billions of other dreaming minds around our beautiful planet, each creating their own unique inner universes while participating in the ancient universal rhythm of human consciousness that connects us all. In cities and villages, in every time zone, as darkness gently falls, human brains are entering this same mysterious state, following patterns that connect every one of us to the deepest aspects of what it means to be alive, aware, and part of this remarkable phenomenon we call consciousness. There's something profoundly comforting about this shared human experience of dreaming that transcends all boundaries of culture, language, geography, and individual difference. Whatever challenges you've faced today, whatever worries or uncertainties you might be carrying, you can trust completely that your sleeping mind will work with them gently, wisely, and with infinite patience. Your dreams may not solve every problem or answer every question that concerns you, but they will absolutely contribute to your ongoing process of growth, understanding, healing, and adaptation to life's beautiful complexity. Thank you so very much for joining me on this exploration of why we dream and the fascinating science behind sleep. Thank you for bringing your wonderful curiosity and sense of wonder to these quiet discoveries about consciousness, creativity, and the truly remarkable capabilities of your own magnificent mind. I'd love to know where you are as you listen to these final words, whether you're settling into your bed for a peaceful night's rest or finding a quiet moment during your day to learn about the mysteries that await you each time you surrender to sleep. If this gentle journey into the science of dreams has brought you comfort, insight, a sense of wonder about your own consciousness, or simply a moment of peaceful reflection, a like truly helps other curious minds discover this quiet corner of the internet where science and sleep intertwine in the most beautiful ways. Your support helps create and sustain a community of people who appreciate both the practical benefits of understanding sleep and the deeper, more mysterious aspects of human awareness that science continues to explore. As you prepare for sleep tonight, or whenever your next sleep period arrives, carry with you a deep appreciation for the incredible journey your consciousness is about to undertake. Your dreams tonight will be absolutely unique to you, created from the specific and irreplaceable constellation of your memories, emotions, relationships, and life experiences. They will be simultaneously the most private and most universal of all human experiences, connecting you to your deepest self while linking you to the shared mystery of human consciousness. May your sleep tonight be deep and truly restorative, your dreams vivid and meaningful in ways that nourish your soul, and your waking tomorrow refreshed and renewed by the nightly gifts your mind provides. Sweet dreams, fellow traveler in the vast and beautiful mystery of consciousness. Rest peacefully, knowing with complete certainty that your sleeping mind will care for you with ancient wisdom that has been lovingly perfected across millions of years of evolution. Until we meet again in another quiet corner where curiosity and wonder dance together in perfect harmony, where science reveals the hidden beauty in everyday experiences, and where the deepest mysteries of being human unfold, like flowers blooming in the gentle, eternal light of understanding and appreciation. Sleep peacefully, dream beautifully, and wake tomorrow morning a little bit changed, a little bit healed, a little bit more integrated by the nightly miracle of dreaming consciousness that connects us all.